we are at Power Focus Area 3, the last objective of Wave Basics. It's kind of an easy objective if you really look at the pictures of the wave, because the definitions are basically just descriptions of the pictures, and I'll show you what I mean here on this first slide. 4 words we're going to need to know here are crest, trough, wavelength, and amplitude, numbered 1 through 4 over there. And I'm betting you can define most, if not all of them, just by looking at the picture and describing what you see. So press pause before I give you the answers and try to define those 4 words just by looking at the picture and describing what you see. All right, hopefully you came up with definitions like this or similar to this, because when we look at the picture and the first word, crest, well, it's pointing to the highest part, or the top, or the pinnacle, or the highest part of a wave. That's all it is. Look at, here's another crest, because it's just as high. Here's another crest. Down here, here's the crest, and here's the crest. So the crest is just the top or the highest point of a wave. And if we look at the next word, trough, it's the opposite. It's the bottom or the lowest point of a wave. Pretty easy if you look at the picture and just kind of remember crest top, trough bottom, and you're good. If we look down here, the wavelength, it says it goes from here to here. Well, what is that top of the wave point called? We just said it's the crest. So the definition of the wavelength is the distance from one crest to the next. If I draw this in, that's also a wavelength, and it would be the same number. Up top, I can draw one wavelength and then a second wavelength. As long as I just keep going crest to crest, it's a wavelength. I could go trough to trough too, that would be the same. Last but not least, amplitude, which they define down here, and they even put an arrow showing you it's from here to here. Well, if we look here, rest position is this long line in the middle, and amplitude goes from rest position to the highest point or to the crest. So that's the definition. The amplitude is the distance from the resting point or resting position to the crest or trough. You could always say trough because the lowest and highest point are the same distance from the middle point. One's just above and one's below the resting point. So look at this picture, press pause before I give you the answers, and try to describe 2 differences between the 2 waves you see. Try to use some of your vocabulary that you just learned on the last slide. All right, if we look here in the first picture, it has a bigger amplitude. And what was amplitude again? Amplitude is the distance from this resting, the middle line, to the top, the crest, or to the trough. And if we look in picture 1, it's definitely taller. The amplitude that I drew here and here are bigger than the little amplitudes in the second wave. The next thing we see is there are more crests, 1, 2, 3, 4, 5, 6 in the second picture than the 3 in the top. So the top has 3 crests, the bottom has 6. And that really introduces a new word called frequency. If you look over there, that third word, it says frequency is the number of waves that pass a point in a certain amount of time. The amount doesn't matter. You can define time as 1 second, 10, whatever. But if we say all of these waves will pass this line in 2 seconds. Well, which one has more crests, more waves? The bottom one, so it has a higher frequency. You wouldn't have known that word, but I hope you at least saw that it has more crests. And now we know if more crests are in a same sized picture or same amount of time, then that just means there's a higher frequency for that wave. Longitudinal waves, remember the waves that go side to side or parallel, they're a little different. So the way we measure their amplitude is not the same, because there is no resting position down the middle like there is in the transverse waves we just showed you. So the amplitude in a longitudinal wave is just the distance between the closest 2 parts of the wave. They call it compressions, so the areas where they're compressed or pushed together the most. Now, if we have a big amplitude, I'll draw it up top of a transverse wave. It's up top because there's a lot of energy. It's pushing it, and it gives it so much energy the amplitude is higher. In a wave that's moving side to side and back and forth, this longitudinal wave, the bigger the amplitude, the smaller the amplitude, the more they get pushed together, the more energy there is. So that's also a difference. But realistically, for our content assessment, the biggest thing to remember is the transverse wave. Amplitude up top here I'm drawing goes from the resting position to the top, or the resting position to the bottom. I think our last vocabulary word for this last objective is called period. And think in school, when you're in school, even at home, with school being online like it is right now, or if you're watching this in the future, it was during 2020, a period is an amount of time. So with a wave, it's the amount of time it takes one full wave to pass a point. And a full wave is defined as a crest and a trough. So in this picture, I have one trough and one crest. So what I just drew is one full wave, the top and bottom part, the crest up here, the trough down here. And if you look, it took 4 seconds for that particular wave to pass, so it has a period of 4. Could I start at 2 and do the same thing? Well, if I start at 2, here's an up, a crest, and a down, a trough. It goes from 6 to 2. Well, 6 minus 2 still gives us a period of 4. So it doesn't matter where you use. I like to start at 0 because then I just look at the number where it crosses for the first time, the full wave, and I know my period, but anywhere you did it would work. So in this picture, let's review real quickly. Which of these waves has a bigger amplitude? Hopefully you said the top one, because again, resting position in the middle to the crest, that's my amplitude, and it's much smaller in the second. So remember, amplitude is from the middle or the resting position to the tallest part, the crest. And in picture 1, that's a much bigger line I drew than picture 2. Which of these longitudinal waves has a bigger amplitude? Now this won't be on your content assessment, but it is worth knowing. We said the areas where they're pushed together the closest is the amplitude. So in here, it's probably looking like, I don't know, maybe in here and in here. That's the amplitude. But look how close they are here. I can't even draw small enough. The smaller the this one would have more energy down here, but it has a smaller amplitude. This has a bigger amplitude because there's more space between the closest 2 compression areas. If you took notes on your own while watching this video, make sure you have a labeled picture of a transverse wave, like in that first slide, and define these 6 words, and then you should be good for the content assessment.